Hey, 20-1s. In this lesson, what we're going to look at is our first lesson in quadratics, and we're going to look at something known as vertex form. But before we get to what the heck vertex form is, let's talk about what this unit's going to look like. In this unit, what we'll do is we will look at what are known as polynomial functions of degree 2. So when I say degree, I'm talking about the highest exponent that I see, so x squared. In grade 10, we only looked at polynomials of degree 1, which we called linear. When we get to grade 12, we'll go higher than 2. We'll go from degree 3 to degree 5. So again, degree is that highest exponent we see. So what does this look like in grade 11? Our most basic degree 2 is known as a quadratic, and it's y is equal to x squared, or f at x is equal to x squared. What we need to know about this graph are some major key characteristics, and you should have this memorized. This is your basic graph. Everything's going to relate back to here. Okay, what are our key characteristics? Well, the biggest one may be the vertex. That's this point right here. So the vertex is the max or the min. In this case, it's the minimum part of the graph. Okay, so the vertex is an x or y and y coordinate. On this one, our most basic graph, it's at 0, 0. Direction of opening. Well, this graph is opening up. So it's either going to be up or down. We never have side to side in high school, maybe in calculus. So direction of opening, up or down. Max or min value. Well, our minimum value, that's a y value, right? A max or a min is always going to be a y value. Well, in this case, we're going to say that the min is at 0. Axis of symmetry. What is that? Well, I'm going to draw in an imaginary line here. I guess it's not so imaginary because I'm drawing it. I'm going to cut this graph in half. Do you notice if you folded the graph over that pink line I drew there, that this graph would be symmetrical about that pink line? So that's known as the axis of symmetry. So that would be at 0 as well. This is at x is equal to 0. So what I want you to notice right off the bat is that the max or the min and the axis of symmetry both go through the vertex. So this is really important right here. The vertex is an x and a y, and it goes like this. It's your axis of symmetry, that's your x value, comma, your max or your min. So yes, it's an x and a y, but it also is two different things. Domain and range. Well, this graph never stops going to the left, it never stops going to the right, so the domain will be the real numbers. And the graph clearly has a minimum at 0, so we have our range. So our domain, x such that x is an element of the reals, and our range, all of our y values are greater than or equal to 0. Y-intercept, well, our original one is at 0, 0, and originally our x-intercept is at 0, 0. So again, this is only for our most basic graph. And then how does the graph begin? How does the graph end? Well, when we say begin, what we're going to do is we're going to read a graph from left to right, just like we read English. So I'm going to say it's beginning up and it's ending up. So I'm going to say this begins up and ends up. Now, you must memorize this. You must memorize these facts of x squared, because what we're going to do now is we're going to start transforming it, which means we're going to start changing how it looks. So those are your basics. Before we start transforming it, we need to know that there's two ways, two common ways at least, to write a quadratic. So as they get more complicated, we're going to add in some more variables here. So this one here is standard form, and the one we're going to focus on right now is known as vertex form. just like that. Okay. Vertex form, we will spend a few lessons working on, and we're also going to spend some time working on how do we switch between these two forms. But these are our two major forms that we play around with in 20-1. So our job here now is to talk about what do these parameters A, P, and Q tell us about the graph. Here's what they tell you. The A value. If A is positive, so if A is bigger than 0, the graph opens up. If the A value is less than 0, the graph will open down. Now, if we change the A value, we make it a 2, a 3, a 4, that's going to be known as a vertical stretch. So it also vertically stretches. So when we say vertical, we're talking about the Y values. So we're vertically stretching. So we're multiplying the Y values by this number. So there's what the A value does. Tells us if we open up or down, and it stretches our graph vertically. P moves our graph horizontally. So this is called a horizontal translation. It's going to move our graph left and right. Now, how this goes is it's going to go the opposite way. So if this was x minus 2, it's going to move us 2 units right. And if it was x plus 3, it would go 3 units to the left. Okay, so P moves our graph left and right, and Q is going to move our graph then up and down, and we call that then vertical translation. So if I said this was Q was 3, it's going to move us up 3. And if Q was minus 2, it's going to move us down 2. So we just need to remember horizontal translation. We move the opposite of the sign. And the vertical translation, we go the same way. Okay, let's play around with these a little bit more. So here's a very normal question. The function f at x is equal to x squared is transformed, so it means it's been changed to become this new function. Analyze and describe the transformations that have occurred. Okay, so here's all we're going to do. So we're going to look at each of these values, the 2, the 3, and the -4. So what do we know? The 2 is our A value. That's our vertical stretch. So we vertically stretched by a factor of 2. What that means is we multiplied all the Y values by 2. Okay, that's what it means to vertically stretch. Then the 3. Well, the 3 is a horizontal translation. And the thing to remember here is it goes the opposite direction. So it's a horizontal translation, 3 units left. The -4. Well, the -4 is a vertical translation. So we're vertical translation, 4 units, and this one vertical goes the same direction, down. There it is. Okay, why do we want to think about these transformations? Well, the reason is this. We can now figure out all of this following information without using our graphing calculator. Okay, this is why we want to be able to do this. So what we did here is we transformed our original function to this function. So let's figure out where all these new pieces of information are. Where is our new vertex? Well, originally our vertex is at 0, 0. But we just said we moved our graph 3 left. That's -3. And we said that we moved it 4 down. -4. There's our new vertex. Direction of opening. Well, A is greater than 0. In fact, A is 2. So it's positive. That means we open up. Max or min? Well, since we're opening up, we have to have a min. What is that min? It's the y coordinate of the vertex. So we have a minimum at y is equal to -4. Axis of symmetry. That's that line that cuts our graph in half. Well, that's the x coordinate of the vertex. So do you see how these two pieces here came from the vertex? The vertex is the axis, comma, the max or the min. So that's why that vertex is so important. Domain. Our domain will always be the reals unless we're an application question. So that's one easy mark on the test. And range, well, we're opening up and our minimum's at -4. So all of our y values have to be greater than or equal to -4. Look at what we're able to do. We can draw a pretty rough sketch of this without having to use our calculator. Just like that. So we've got a really good looking graph here, just based off of this vertex form. So that's why the vertex form is going to be so important. Given the vertex form, we can draw a good graph. Y-intercept. Okay, the y-intercept, we need to think of the actual function that was given to us. So the function that was given to us was 2x plus 3 squared minus 4. How do we find a y-intercept? Well, to find a y-intercept, I'm going to always let x equal 0. So all we have to do is sub in 0 and solve for y. And that'll be 14. So our y-intercept is at 0, 14. So look at, I didn't draw my graph very well now, did I? Let's fix that just a touch, hey? So now we know our y-intercept's way up here at 14. We've got our vertex down there at -3, 14, -3, 4, I should say. And so look at, like, we've got a pretty darn good looking graph based on just the vertex. Not bad at all. All right, last thing we're going to do. We just use the function to draw the graph. Okay, but what if we don't have the function? What if we have to create the function? Here's what we're going to do. We'll learn how to make the equation in vertex form. So what do we have? We've got the x-intercepts at -2, 7, -2 and 7 with a minimum of -8. Okay, first thing I'm going to do, always draw a visual. So I've got a x-intercept right here, an x-intercept right here, and it says we've got a minimum of -8. Okay, but where is that minimum? Well, remember, quadratics are symmetrical. So if we know where two x-intercepts are, our axis of symmetry has to be directly in between. I'm just going to draw an axis right there. Well, how do we find that? Well, what's halfway in between -2 and 7? Well, our axis is the average of those 2 points. So I'm going to add them together and divide by 2, which is 2.5. So the axis of symmetry is at 2.5. And we know the minimum is at -8. So down here somewhere is our vertex, -2.5, -8. And there's our graph. So that's what the graph looks like. But now how do we get the equation? Well, we're going to use vertex form. So let's write down our formula. What does this look like? And let's start subbing in information we know. Well, we know right off the bat where the vertex is. So that's P and Q. Just remember, if we're at negative 2.5, we go the opposite way, positive 2.5. And the minimum tells us we went down negative 8. Okay, but we're missing A. How do we find A? Well, to find A, I'm going to sub in one of my x-intercepts. Doesn't matter which one. I'm going to sub in, let's say, negative 2. So that's when y is 0, A, negative 2 plus 2.5 squared minus 8. And now all we've got to do is slowly isolate for A. So I'm going to add 8 to both sides. I'm going to simplify what's inside my parentheses here. So that's 0.5 squared, just like that. 0.5 squared is 0.25a. And so now we're going to divide both sides by 0.25 or divide both sides by a quarter, and that'll be 32. So our equation then is 32x plus 2.5 squared minus 8. There it is. So again, what we did, drew a pretty picture, thought about what the given information helped me with, and the biggest thing we really need here is we need this vertex. Okay, let's try one more. What do we know on this one? Says we have an axis of symmetry at negative 4 with a range of negative infinity to negative 3. Okay, so axis of symmetry is at negative 4, so it's somewhere over here. Negative 4. And then the range is negative infinity to negative 3. Well, what does that tell me? Well, it tells me that my graph is opening down with a vertex with a y value, a maximum of negative 3. So I know my graph looks roughly like that. Well, look at, now I know my vertex is at negative 4, negative 3. So on both these questions, we're really getting the vertex, but it's just hidden to us. We can't just read it right off the bat. Now that we know that vertex, we use vertex form. We sub in our values. Remember, the x goes the opposite way, just like that. Now we want to find the a value. Okay, well, how are we going to find the a value? Well, to find the a value, we're going to need another point. Now, I failed to give us another point here, so let's just make one up. Let's say that our, one more piece of information, let's say our y-intercept is at, oh, I don't know, what's a good sounding y-intercept? 0, negative 10. So we would have had to have had one more point to sub into our information. My apologies. So I'm going to sub that point in. So I said it was at negative 10. And again, same as the other question, we just need to solve. So I'm going to add 3 over. 4 squared is 16, so that's 16a. Divide both sides by 16. And there we go. It's negative like it should be because this graph is opening down. So x plus 4 squared minus 3. So when we go to make the equation of a quadratic in vertex form, so when we're using this, what we always want to do is first we want to find our vertex and sub that in. So I do that first. And then what we do after that is to find the a value, we're going to sub in another point. And we'll do that second. That's our second step. Okay, friends, there is what a basic graph looks like. So make sure you've got all the basics of x squared memorized, and you'll just learn how to transform it in vertex form. See you next time.